Hi. In calculus, we have a basic method which is called substitution in integration. For example, we have an integral 6x plus 5 to the power of 3 dx. Well, of course, we are doing it by substitution. You let u be 6x plus 5, then du is equal to 6 dx, then dx is equal to du over 6. Then we substitute these into the integral. We have integral u cubed 6d, right? Then you have 6 4 u to the 4th plus c. Then you substitute u back, you get 3 over 2 6x plus 5 to the power of 4 plus c. Okay, this is a basic substitution method. Now, what I want to do is this. You know, sometimes these substitution is a very easy and simple. Then you don't have to detailize these process. So I suggest, we have a nice way to do it. So we are given 6x plus 5 to the power of 3 dx. Okay. From first look at this one, we know that this integral is using the power formula, right? We are using this one. We are using something to 3 and a d something. And this integral, right? Now, since I'm not writing equal sign, therefore I can write anything. So I'm going to write what I want. I want something cubed d something. That is basic formula, right? X to the n integral dx is equal to x n plus 1, right? N plus 1 plus c. This is a basic formula. So I want to write this integral into a basic formula, satisfy this one, right? Since I'm not writing equal sign, so I just write anything I want. Now this is a 6x plus 5, so this must be 6x plus 5, 6x plus 5. And this one, this is a 6 dx. Now we have only 1 dx, so 6s dx, so divided by 6. Then I can resume the equal sign. Okay, then equal sign is back. Then I'm using formula. This was 6x plus 5 to the power over 4 divided by 4 plus c. Now in this way, I skip the detail of the substitutions. Okay, so this I think is good for us to do integration straightforward without being interrupted by the substitution details. Okay, this is the method I want to introduce today. Now let's do more examples. Integral e to the 4x plus 3 dx. Now obviously that we try to integrate by using basic formula, that is e to something d something, right, is equal to e to something plus c. That is basic formula. Now I try to apply this basic formula into this integral. So this is the integral e to the 4x plus 3 d 4x plus 3. This is what I want for that formula. And since I'm not writing equal sign, therefore I can write anything. Of course, then since we are doing this integral, therefore we have to consider equal signs back. So this is equal to this. So the equal sign has to be considered dx and a d 4x plus 3. So this is equal to 4 dx. This is a dx. So multiply by 1/4. See, that will be equals. So the equal sign is back. So then this is equal to 1/4 e to the 4x plus 3, right? Plus c. So in doing this way, I skipped the substitution. I skip the u business. So this is a very convenient and practical and nice way to do integrals when the integration is not that complicated. Okay, let's do another one. Say x e to the 3x square. Okay, now by look at this one, of course now dx, I want to use this formula, right? This is the basic formula. E to something d something is equal to e to something plus c. Now this integral is not perfectly fit for formula, but I want to write down this is what I want to do. D 3x squared, right? So this is this. This is this formula, right? Now, no equal sign. I can write anything. But I must put up the equal sign here. Then I have to consider this one and that one. So this one is a 6x dx. This derivative, this differentiate is a 6x dx. Now we have a x dx. You have a 6x dx. So to cancel that 6, multiply 6, right? Then the equal sign back. So this one is 106 e to the 3x squared plus c. Now doing this way, I skipped the detailed substitution, right? Substitution, you have to put a u, and then afterwards you have to put a u back, for u back for x. So this method, I believe, is very nice way to integrate. Let's consider another example. Another example, say this example. Integral x dx 7x squared plus 2. Okay, this integral, all right. Now, you must have an idea what is the basic formula you are going to do. We must have something in mind before we are going to try to fit for what you think, what is your mind. See, what is in my mind? My mind is this: d something over something. This is the basic formula in my mind. This is a log, right? Star plus 1. Yeah, okay, that is basic formula. Now, by considering this given integral, the denominator is this, right? So I'm writing 7x squared plus 2 and a d 7x squared plus 2. Okay, if this is 1, right? This is a 1. to fit for the formula. Now, if I can successfully write this one as this, and I finished, because the end, this one is equal to the log, right? Is equal to log of this, but they're not equal. They're not equal. I try to put them equal. So this one is a 14x dx. This one, this is equal to 14x dx. I have only one x dx. 14x. I just balance it by divided by 14. Then I put the equal sign back. Okay, then this is a 14 log 7x plus 2, right? Plus c. See, this is positive. So, okay, that's finished. You know, doing this way, we skip the detail of a substitution. We skip the U business. So for us, it's very, very nice. You know, your integration is straightforward without any interruption. Well, let's think another one. I think this method is particularly for the students who take calculus in the first place. You know, in the beginning, that you can easily, you know, have a techniques to deal with integration without some interruption. Okay, let's do another integral. This is integral x dx and 1 plus x fourth. Okay, now you must have an idea. You must have something in your mind that the basic techniques you are going to attack. Basic formula rather, must be something in your mind that I'm trying some basic formula for that integral. So the basic formula, of course, is this, right? D something 1 plus something square, that integral. The basic formula is arctangent, right? Arctangent something plus c. So this is something in your mind. I try to put up this one into this kind of form. So I'm writing d 1 x square x square, right? So this is, see, has to be x square, right? X square. So if I can successfully transform this integral into that one, then we can apply this formula we finished. But here is that it's not equal. Now I didn't put the equal sign yet. I tried to put the equal sign back. So this one is a 2x dx. This is a 1x dx. 2x dx, 1x dx. So multiply by 1/2. Then this equals the equal sign back, right? So this one is equal to 1/2 arctangent x square plus c. Now by doing this way, we forget the U business. We forget the U. We forget substitution. We can omit writing many steps, not many, but some steps for basic substitution. This one is a straightforward without any interruption. It's a very, very practical method for integration, because later you are dealing with more complicated integrations. You will pay more attention on the techniques of dealing with the integral, And these are minor things. These basic substitution could be forget by straightforward, doing like this. It's a very, very practical method. I hope that everybody can do this, and everybody can master this techniques. Okay, let me put some more methods to practice this useful technique. Okay, let me do another thing, another integral. How about 3e to the power of x dx over square root 1 minus e to the power of 2x. Now, look at this integral. What is in your mind, What is in your mind? I mean that what is your mind for the basic integral? So, I hope that we have this in. You have this one in our mind, that is d something square root 1 minus square something square. So that is arcsine something. Let's see. So if you have this one in your mind, we can try this integral fit for that basic formula, which means that we have a square root 1 minus e to the x square, right? We try to write something which is a fitting for that basic formula. Since there's no equal sign, I can write anything, right? I can write anything. I can write a poem, as long as there's no equal sign. But since we are doing this integral, therefore we must consider that equal sign back. That is our technique, That is what we are going to do. So this one is my star. I must put d e to the x, right? You see, that's fit for the formula, but does not fit for that one. By considering they are equal, I must to balance something. This is a 3ex dx. This one is ex dx. You see? This is ex dx. This is 3ex dx. They have multiplied 1/3. Then we have equal sign back. Once my equal sign is back, then this is done. Because I simply use the formula. This is 1/3 arcsine, right? E to the x plus c, right? Yeah. Okay, that's done. This method is so good that we don't have to consider u. We don't have to detailize the u. We do not interrupt the process of integration. We just go straight forward. See, this is a truly useful, practical, nice way of doing integrations. Okay, let's consider another one. Integral sine x cosine cube x dx. It looks very complicated, right? But if you look at nicely, that cosine is the derivative. Sine is a derivative of cosine. So if sine is derivative of cosine, then the main function in the integral in integrand is a power function. I'll repeat again. This looks very complicated, but if if you realize that sine x dx is the d cosine x, but negative, right? Therefore, this one becomes the power function. This becomes a power function, d something. This is d fourth over 4, right? Plus c. So, okay, if you can see the structure, something like this, then it's very easy to continue. Okay, this is a cosine cube x, right? D cosine x, right? Cosine x. No equal sign. I can write anything. I try to write something which is good for my formula. So now, this one is a fit for the formula, but no, not equal. But when you consider this carefully, this is a negative sine dx. Negative sine x dx. I have a positive sine x dx, so I put a negative here. Then they're equal. So then this one's a negative cosine fourth x over 4 here. So that's been done. It's a nice way, once it's straightforward. You don't have to start with like let u be cosine x, then du is a negative sine x dx, then you put a u into the integral, then you finish the integration, then you put a u back again. You know, here it's just straightforward. So this, I think, is a very useful method to deal with basic integrations. Okay, let's consider another example. How about this one? Tangent square x secant x dx. Yeah. Now, what to do? How do we deal with this one? Now, look, this one looks very complicated. Let me change it to 3, okay? See, the reason change to 3 because it's easy for us to do the method. If it's square, I know we need something else. Now, this. Okay, you are dealing with the trig functions. But if you can consider that the derivative of a dx, now integration with respect to x, this is very complicated. If we change the variable, for example, we change secant as an example. The derivative of secant x is secant x, tangent x, and the dx. Right? If we change the structure of this integral into the basic variable as a secant x, then it's been changed. It changes everything. So this is a tangent square x, right? D secant x. Okay. Here's the secant x derivative is this. Now, we are integrated with respect to secant now. So this one has to be in terms of secant. This one is we are integrated with respect to x. So every variable must be in terms of x. If we integrate with respect to secant x, this has to be secant x, then we can integrate, right? So this one is a secant square x minus 1, right? That's a tangent square. And then d secant. See, now it's totally different that we change the name of the game. We change the name of the game from x to secant. This one is equal to that one. This is equal. This one is equal to that one. Is equal. Okay. Then this one is equal to secant squared d secant. That is secant cube x, right, over 3 minus d secant is secant plus c. Okay, so finished. Yeah, we'll be finished. Now, this integral is good because we do not use u substitution. We do not have a let u be something, and you put a u back and change everything to u. After integration, then you put a u back for the x, which is straightforward. You know, substitution is our in mind, and without being interrupted. You know, just go through. Of course, you can simplify this one. Simplify into 3 secant x. Then this one is secant square minus 1, right? Plus c. This is a secant 10. So this is equal to 1/3, right? Secant x and the tangent square x. All right, this is another story. It's algebra. The result is nicer. Okay, this is a. Don't you think this is a very nice way? You know, from here to there without any interruption. Just go straight. Without let's just stop over. Let's introduce u back, and then finish it. Put a u back again. See, these are just one shot. You know, one straightforward. Okay, let's do one more. One more. This is say secant 4th x dx. Now we cannot integrate directly because there's no formula, right? We forget the reduction formula. So we cannot apply any basic integral formula to get the result. So we have to consider changes. This one changes for secant square x, right? Times secant square x dx. Now, what to do? This integral is complicated because we are integrating with respect to x. If we change the variable, this integral may not be necessarily difficult. For example, this one is what? This is a d tangent x. This is a d tangent x. Tangent x is derivative is secant x squared, right? So I try to make this integration integrate with respect to x into integrate with respect to tangent x. That means everything before it, if I can change it to tangent x, I win. Change this one to tangent x, which is possible. This is equal to 1 plus tangent square, right? Now this is equal. Then integration is done because we are integrated with respect to x. But we are integrated with respect to tangent x. So this one, d tangent x is tangent x. This one is basic formula, tangent cube x over 3, right? Because you are dealing with tangent x. So that means that we are dealing with this, right? 2d. We are doing this one. This is this. This is equal to 3 star, right? Plus C. So we finished. Now, if you want to put it nicely in the result, that's another story, right? We just common factor. This one is tangent x, and there's a 3 plus tangent square. Oh, this is just algebra, okay? It looks better than that. Now, let me finally summarize that this method, what I'm introduced today, is a method. We can omit this u, substitution, let u be something, and after integration put the u back. But all these we can forget, but just go straightforward by considering, by bringing new variable which can satisfy their basic formula. Okay, I hope you like it. Thank you for your watching.